Hi guys, this is the Innovative Minds Tutor. We will be looking at November 2023 as we are revising for November 2024 paper 1. So now we are going to work with question 8. On our previous video, we did look at that beautiful 13 marks. So now also look at another beautiful 18 marks that we need to collect. If you are new to this channel, what are you waiting for? Kindly subscribe. You only subscribe once. So given that negative x cubed plus x squared minus 9x plus 4 is equals to the factorized expression on the right hand side. So then they said determine the coordinates of the turning point of f. When they say the turning point of a cubic equation, we always gonna derive. It's a first derivative. Do you hear? We are going to derive. So let's put that into practice. So from here at 8.1, remember that we're given f of x is equals to negative x cubed plus 6x squared minus 9x plus 4. So I am going to derive. Remember I told you that the turning point will be the first derivative and you equate to 0. No? So what am I going to do? Let's derive this. Derivative of f of x. Negative 1 times 3, that will be negative 3x. Subtract the power using a power rule. That will be x squared. 6 times 2, that will be 12 minus 1, that will be 12x. Negative 9 times the power of 1, that will be negative 9. 1 minus 1, that will be 0. Any base power to the 0, it will be 1. 9 times 1, it's 9. Remember? So we will need to now equate to 0. So this will be 3x squared plus 12x. It gives us a quadratic equation. So what do we do? Because we need to find x, let's divide everything by negative 3. Here we are going to get 0, negative and negative. We are going to have positive x squared. So what is 12 divided by 3? 12 divided by 3, that's 4. So we are going to have 4x. How many times does 3 goes to 9? It goes 3 times. So that will be minus 3. So from here, I will need to factorize. Factors of 3, that will be 3 and 1. So here will be, because we are going to have, okay. Right, the signs. So since it's negative here, we're going to have different signs, right? Well, let me check the sign very well. So since I divided by negative here, it will be positive. Positive and negative, that will be negative. So I made a mistake here. Negative and negative, that will be positive here. So that will be positive. So since we have positive, they will take a sign of a middle number, which is negative. Both of them will be negative. In other words, negative 3 minus 1, it's negative 4. Negative 3 multiplied by negative 1, positive 3. So we have 0, which is equals to x minus 3, or x minus 1 equated to 0. So if I take negative 3, I'm going to have positive. So it's going to be 3 is equals to x, or x is equals to 1. So in this case, I'm having x is 1, also having x is 3. So they said the coordinates. Let's start with 1. We are going to substitute to the original. Go to the original equation. Where you see x, you put 3. Let's start with 3. Cube plus 6, 3 squared, then minus 9 times 3 plus 4. What are we getting? We're getting, sorry for here, it's 3 and 4. So for 1, let's see what we get if we put 1. Go back and substitute to the original equation. So we have 1 here. We have 1. Then that's 1 and 0. So that's the turning points. Those are the turning points. Hope you did see how we work out that beautiful 4 marks. Let's go to 8.2. For 8.2, draw a sketch of f. Clearly show all the x-intercept with x's and any turning points, right? So we already have the turning points. I guess we need to calculate for the x-intercept, right? I guess we need to, not guessing actually, I know we need to calculate the x-intercepts. Well, for the x-intercepts, I'll use a short division, or you can use a k-mat dot. So we are going to take from the original, the coefficients. Coefficient of negative x cubed, that will be negative 1. Coefficient of x squared, that will be 6. Coefficient of negative of x, that will be negative 9. And then we take the constant, which is 4. So when you are there, guys, you need to find a factor. So we need to find the factor that will substitute here, that will give us 0, right? So we'll find the factor. Let me start with 1. Let me substitute 1 there on the original. What I get is 0. So meaning that my x minus 1, it's a factor. So I'm going to take that 1 here. If you're using a synthetic division, then you're going to drop this negative 1 here. Right? So after that, you are going to multiply. What is 1 times negative 1? That will be negative 1. So negative 1 plus 6, let's go. Negative 1, negative 1 plus 6. What is that? It's going to be 5. Right? So we do the same thing as well. So we are going to say 1 times 5. 1 times 5. That will be 5. You place 5 here. At the third number, then you say 5 plus negative 9. What is that? It's negative 4. Then from here, what is negative 4 times 1? That will be negative 4. Negative 4 plus 4, that will be 0. So in other words, this is the expression I'm having. This is the expression I'm having. I'm having negative x squared plus 5x minus 4, which is equated to 0. So divide everything by negative. I'm having x squared minus 5x plus 4 equated to 0. So the like terms, the like terms. To be smart, what are the like terms? It's 4 and 1. So they will take a sign of a middle term since it's positive here. So we are going to have x is equals to 4, or x is equals to 1. So this is 4 and 0, and this is 1 and 0. So I will have to go to the original equation and substitute zeros for me to get the y-intercept. Zero squared minus 9 times 0 plus 4. So the y-intercept is 0 and 4. So so now I will need to sketch. Let's put this into practice, right? So we can see that 1 and 0 is also on a turning point. That means they share a point, right? So we have 0 as well as let's put also have 0 and 1 here. 1 and 0, meaning the x-intercept and the y and the turning point, they share. Then we also have the other x-intercept, which is 4. So it's 1, 2, 3, 4. So we are going to have 4 and 0. So we also have 3 and 4. So 3 and 4 will be somewhere here. So 3 will be somewhere in between. Then 4, it will go 4 times there. So we'll have our turning point as 3 and 4. Then our y-intercept is given as 0 and 4. 0, 1, 2, 3, 4. So we are having 0 and 4 there. I guess now we can connect our dots. So this is the sketch, this is y, and this is x. You have already shown your x-intercept as well as your turning points. That's a beautiful 10 marks, and you get it for free. That's how we are doing it at 8.4. Let's go to 8. For 8.3, they said use the graph to determine the values of x for which negative x cubed plus x squared minus 9x plus 4 is equals to k will have real and unequal roots. That is actually happening at the turning point. Yes, at maximum. It will happen at where there is maximum, at maximum. So where am I talking to? This is where it happens, guys. We are looking at 8.3. They want us to find, they said use the graph to determine the value of x, for which negative x cubed plus 6x squared minus 9x plus 4 is equals to k will have 3 roots and unequal roots. This will happen, we'll look at where it goes upward for 4 units, but we don't know. It goes upward vertically, horizontally, we don't know. So in this case, what am I going to do for 8.3? You're going to have this solution. Your solution will be 0 is less than k, 0 is greater than k, but lesser than 4. So that's how we can calculate 8.3. I hope I do make sense. If I don't, kindly tell, right, so that we learn. There's always a room for learning, guys. Let's go to 8.4 now. At 8.4, they said the line y is equals to ax plus b is the tangent to f at the point of inflection. The point of inflection is always the what? Is always the second derivative. I want you to know that it's always the second derivative, meaning we will have to find the second derivative so that we can get that beautiful 6 marks, right? So let's put that into practice. Well, we are at 8.5. So for you to get, we need to find the gradient of a tangent here first. But we will use, remember, we were given f of x is equals to negative x cubed plus the original equation. I'm going to the original. 6x squared minus 9x plus 4. For you to find the first one, we did say that this will be negative 3x squared plus 12x minus 9. So for the second derivative, so that we can find the x turning point of a point of inflection. So what do we do here? We are going to say negative 3 times 2, that will be 6, negative 6x, then 12 times 1, that will be 12, 1 minus 1, that will be 0, x to the power 0, it's 1, 1 times 12, it's 12. So remember, we also have to equate to 0 as well here. So we have negative 6x plus 12. You can take negative 6 to the other side, it becomes positive 6, which is equals to 12, divide everything by 6. So this and this, how many times does 6 goes into 12? It goes twice. So that's the x turning point of a point of inflection. Then we go back and substitute to the original. When we substitute to the original, what do you get? You get 2. So this will be 2 and 2 as our coordinate. So to find the gradient of a tangent, we will need to do this. Well, we will need to be smarter. So we will have to go and find the gradient of a tangent. So when you find the gradient of a tangent, it will be easy for you to work out this. So the best way is to go and substitute in this equation for the first derivative. The gradient of a tangent is always the first derivative. So I will prefer to substitute here so that I get mt, which is the gradient of a tangent. So when you get it, you are going to have 3. So that will be 3. Mt will be 3 in this case. So you're having mt as 3. So we need to find the equation, remember? So y is equals to mx plus c. Our gradient, we already know it's 3x. So plus c, we can use this coordinate, x and y. Where there's y, you put 2. Where there's x, you put 2 as well. So this will be 3 times 2, which is 6. If we take 6, 2 minus 6, that will be negative 4. So the equation will be 3x minus 4. So that's how you can work out 8.4. You just have to know the techniques. The gradient of a tangent, it's always the first derivative. Let's go to the last question then. The last question, they said, calculate the value of theta, the acute angle formed between G and the x-axis in the first quadrant. This is a gradient of inclination. In other words, we are going to use the formula m is equals to tan theta in this case, right? So it's going to be tan theta is equals to the gradient that we have calculated. The gradient of tangent was 3 there. So at 8.5, we are going to have tan theta is equals to m. We did have a gradient there. Tan theta is equals to 3. Then second function, you're going to say tan arc of 3. Then I want you to punch your calculator there. Shift tan arc of 3. What is that? That will be 71. Correct it to decimal place. That will be 71,57 degrees. That's our beautiful theta. That's how we can get that beautiful 18 marks. I hope, guys, that fear of calculus will stop. We need to fight this, guys. We need to fight this. See you on our question 9. On our question 9, let me show you what we are going to do at question 9. So we are going to look at a mathematical modeling or an application of calculus at question 9. So that's what we are going to look at. If you're new to this channel, what are you waiting for? Kindly subscribe. You only subscribe once. And remember, we wish you all the best in your examination on November 2024. We love you.